The paper provides a comprehensive review of application state management (ASM) techniques in modern web and mobile applications, categorizing them into three main categories: local state management libraries, and server-side state management. In the realm of local state management, the paper explores state management mechanisms in popular user interface development frameworks such as useState in React, component properties in Angular, and data properties in Vue. These frameworks are chosen due to their prominence in building the UI of modern applications, as indicated by the survey conducted by the State of JS. State management libraries are also analyzed, including Redux, MobX, NGRX, NGXs, Vuex, Recoil, and ZooStand. These libraries aim to streamline an application's data and mutations, making the data predictable at various stages of the lifecycle. This predictability allows all parts of an application to access this data with tools provided by various ASM techniques when required and presented to the user, making the entire application consistent and responsive. Server-side state management techniques, particularly caching, are discussed for their roles in enhancing data retrieval efficiency. The Single Responsibility Principle, SRP, introduced by Robert Martin in 1972, is a key design pattern for web and mobile applications. It states that software components should have only one reason to change, leading to the creation of scalable and maintainable user interface (UI) and application programming interfaces (APIs). The methodology of the review involves an extensive literature review, recent trend surveys conducted by leading organizations, thought leadership pieces published by technology industry experts, and expert opinions from experienced application development experts. This approach has resulted in recommendations that are practical and forward-looking in nature for ASM techniques, moving beyond barriers of just theoretical assessments. The paper aims to bridge the gap between theoretical knowledge and practical application, providing actionable insights for developers to build scalable, responsive applications. It critically analyzes the effectiveness, adoption, current trends, and future scope of these ASM techniques and recommends key use cases, benefits, and disadvantages of using each of these. This research paper examines server-side application state management (ASM) techniques, with a focus on the role of major databases such as Redis and Memcached in caching. According to the 2023 Stack Overflow survey, Redis is a leading storage database used for caching, while other databases are more commonly used for primary use cases that do not typically involve caching mechanisms. The paper also explores traditional databases such as SQL and other key-value pair databases for ASM, as well as server-side ASM technologies like the Blazor server. The paper analyzes various ASM techniques, including expert opinions from developers and architects who have worked with multiple ASM tools and frameworks. Key statistics, such as downloads on popular package managers and stars and forks on GitHub, are used to understand market adoption trends. The research highlights the importance of local state management in handling data related to a single component or section of the user interface, which does not require sharing with other parts of the application. Local state management is crucial in use cases such as form handling, presentation logic changes, and handling notifications and updates. For example, when creating a user sign-up form, local state management can capture user input data and validate it without passing it around the app. In another scenario, a component may offer multiple ways to view data, and local state management can be used to capture the toggle button state in a local state variable. The paper also explores local state management in popular frameworks such as React, Angular, and Vue. In React, local state management can be done using class components with this state variable or functional components with the useState hook. A code snippet demonstrates the use of a local state variable named uploadProgress in a React component, which is dynamically modified upon successful file upload. The examination of local state management in various frameworks provides valuable insights into the role of ASM in handling data efficiently and improving application performance. By highlighting the importance of local state management in specific use cases, the research aims to inform the development of effective ASM techniques that optimize data handling and application performance. The provided code snippets illustrate the implementation of a file upload mechanism in both React and Angular. In the React example, A file upload component is defined using useState hooks to manage state variables for the file and upload progress. The handle file change function updates the file state variable with the selected file, while the handle upload function initiates the upload process by creating a new form data object and appending the file to it. This function also tracks upload progress through an onUpload progress callback, which updates the upload progress state variable. In the Angular example, a similar approach is taken, but with the use of local state variables and lifecycle methods. A file upload component is created, and the upload progress variable is initialized to 0. The handle file change method updates the file state variable, and the handle upload method initiates the upload process by creating a new form data object and appending the file to it. This method also tracks upload progress through an onUpload progress callback, which updates the upload progress state variable. Both examples utilize a POST request to send the file to an API endpoint, and they both display the upload progress and percentage. The React version uses a p tag to display the progress, whereas the Angular version uses template binding to display the progress in the HTML template. These examples demonstrate how state management and lifecycle methods can be utilized in both React and Angular to implement a file upload feature that tracks and displays upload progress. This functionality is crucial for enhancing user experience during file uploads, as it provides real-time feedback on the upload status. In the realm of user interface frameworks, local state management techniques are employed to handle data that does not require sharing across various components in an application. This approach can streamline the application and enhance its performance by efficiently managing data within the scope of a particular component. Modern frameworks such as React, Angular, and Vue each have their own implementation of local state management. For instance, React utilizes state variables in class components and hooks in functional components, while Angular leverages class properties with multiple options for initialization. Vue, on the other hand, uses a special method called data to implement and return local state variables. Local state management techniques can be applied to a wide range of use cases, including form handling, asynchronous operations, and presentation changes limited to the scope of a specific component. However, these techniques are tied to individual frameworks, making it challenging to create interoperability between different applications. Moreover, if not used correctly, local state management can lead to tight coupling between different parts of the application, as too much data needs to be passed around between components, resulting in interdependent components. In contrast, state management libraries allow for the efficient use of data that needs to be shared across multiple parts of the application. This data needs to be consistent when accessed in different sections, requiring a robust mechanism for reliably updating the data. A prime example of this is global state management, where certain information must be shared across many components in an application, and updates to this information must stay consistent throughout the entire application. In an e-commerce application, for example, information about items added to the cart must remain consistent when a user is on the cart page, checkout page, item description page, or any other page. Furthermore, the quantity of items can be edited at multiple parts of the application, and this change should be reflected in all other places referring to the data. State management libraries are crucial for efficient data sharing and communication between components in modern web applications. Cross-component communication is a common use case, where data needs to be actively passed between components, such as in an insurance application where users can change various clauses to find the best rate. State management libraries streamline this process, enabling seamless data sharing between parent-child or sibling components. Another essential feature is undo and redo functionality, which allows users to revert actions or cancel reverts. This is particularly useful in interactive applications, such as education platforms, where students can undo and redo steps while solving math problems. State management libraries enable users to travel through time and reapply previous actions. React, Angular, and Vue are popular frameworks for building applications, each with their own state management libraries. For React, this paper focuses on Redux, Recoil, ZooStand, and Mobex. Redux has a single data source, the store, which is shared across the application, making it a single source of truth. The data in the store cannot be modified, and changes are made through reducers, which create a new copy of the store data. Reducers change the data based on events called actions, which are plain JavaScript objects that describe what happened and how the store data should be updated. When an action is dispatched, the reducer function takes the current state and action as arguments and returns a new state. Redux also allows middleware functions to perform extra work, such as calling an API to load data into the store. The Redux flow is demonstrated through an example of a simple account management part in a banking application, where actions such as incrementing and decrementing balances are defined and acted upon by the balance reducer. The balance reducer also defines the initial balance and is taken as an argument when creating the store. Recoil, another popular library, takes a more fine-grained and flexible approach to implementing state management. Application data is broken into smaller units, and Recoil provides a more granular control over state management. The code examples demonstrate how Redux can be used to implement a simple account management part, including actions, reducers, and store creation. In the context of state management in React applications, Recoil and ZooStand are explored as alternatives to Redux. Recoil introduces the concept of atoms, which are independent units of state that can be read and updated by components. Components that subscribe to an atom are re-rendered upon an update. Selectors, special functions in the Recoil library, allow access to an atom's data and handle side effects such as API calls. A basic implementation of a banking system feature, where account balance can be incremented and decremented, is demonstrated using Recoil. This is achieved by defining a balance state atom and creating a balance selector to access the atom's data. Individual components can access and modify the data using the user-recoil state hook. The Recoil implementation does not require the creation of an application-wide data store. Instead, individual components can access and modify the data inside the atom. The user-recoil state hook is used to subscribe to the state value and modify it. In the banking app component, the balance state atom is used to display the current balance, and two buttons are provided to increment and decrement the balance. ZooStand, another state management library, offers a simplified API for implementing global state management. It reduces boilerplate code and relies on React hooks to access and manage state data. ZooStand allows the creation of a single store that can be consumed inside React components, making implementation easier. Middleware integrations are also possible to handle side effects. A basic implementation of the same balance increase and decrease operation is demonstrated using ZooStand. A new hook, useStore, is created using ZooStand's Create API, and the banking app component subscribes to the state value using this hook. The initial state is set to 0, and function definitions for incrementing and decrementing the balance are provided. The research paper discusses the implementation of state management libraries in React applications, specifically focusing on Mobex. Mobex has gained popularity in the React ecosystem due to its robust and flexible approach to state management. It relies on reactive programming and decorators to implement state management, effectively reducing boilerplate code. Mobex breaks down the entire state into small observables, allowing for easy consumption of state data via subscriptions. State can be modified using actions by individual components. Mobex offers functions called reactions to manage side effects, such as handling asynchronous activities. Reactions are functions that automatically run whenever the observable state they depend on changes. The paper provides a sample code implementation of balance increase and decrease functionality for an account in a banking application using Mobex. A new store class is created using the makeAutoObservable API from Mobex inside the class constructor. An instance of this store class is created and exported. A new component is created using the Observer API offered by Mobex, which has access to the value of the balance as well as methods to increment and decrement the balance. The code snippet demonstrates how Mobex can be used to manage state in a React application. The makeAutoObservable function is used to create an observable store, which can be used to manage state. The observer function is used to create a component that can observe the state and react to changes. The paper highlights the benefits of using Mobex for state management, including reduced boilerplate code and easy consumption of state data. The Mobex implementation is compared to other state management libraries, such as Redux and Vuex. The paper argues that MOBEX offers a more flexible and robust approach to state management, making it a popular choice in the React ecosystem. The paper also discusses the limitations and assumptions of using MOBEX for state management and highlights future work in this area. The equations and algorithms presented in the paper are related to reactive programming and decorators, which are used to implement state management in MOBEX. The paper does not provide a detailed mathematical analysis of these concepts, but rather focuses on their application in state management. The figures and tables presented in the paper provide a visual representation of the MOBEX implementation and its benefits. The paper assumes a basic understanding of React and state management concepts. It does not provide a detailed introduction to these topics, but rather focuses on the application of MOBEX in state management. The paper highlights the limitations of MOBEX, including the need for additional setup and configuration. However, it argues that the benefits of using MOBEX outweigh these limitations. Future work in this area includes exploring the use of MOBEX in larger-scale applications and comparing its performance to other state management libraries. Here is the combined summary of pages 15 and 16. The banking app is demonstrated through an Angular application, utilizing NGRX for state management. NGRX combines the power of RxJS with the principles of Redux architecture, providing a single store for data across the entire application that cannot be mutated. It also allows for clean management of side effects and direct integration with Angular Router, boasting robust developer tooling. The NGRX store is implemented in an Angular-based application, with actions for incrementing and decrementing the balance defined inside the balance actions TS file. These actions are used to create the balance reducer, which holds the logic for the initial balance. Selectors are created to consume the state, and the store is initiated inside the app module, allowing any Angular component within the app module to access the store. The balance actions TS file imports create action and props from at NGRX store, defining increment balance and decrement balance actions with props for the amount. The balance reducer TS file imports create reducer and on from at NGRX store, defining the balance state interface and the initial state with an initial balance of 0. The balance reducer is created using create reducer, with on functions handling the increment balance and decrement balance actions to update the state. The balance selectors TS file imports create selector and create feature selector from at NGRX store, defining select balance state and select balance selectors to access the balance state and the balance, respectively. The banking app component utilizes these selectors to display the current balance and updates it accordingly when the increment or decrement buttons are clicked. The research paper discusses state management in single-page applications, focusing on two libraries, NGRX for Angular and Vuex for Vue. It begins by introducing NGRX, which is a library that provides reactive state management for Angular applications. This library relies on the principles of Redux and reactive programming to manage the state of an application. In the given code snippet from page 17, an Angular module is created with the store module imported and configured to use the balance reducer function. This reducer function manages the balance state within the application, allowing it to be increased or decreased through dispatched actions. The select balance state function is used to access the current balance from the store. On page 18, the paper shifts its focus to Vuex, a library used for state management in Vue applications. Vuex also uses the principles of Redux and reactive programming to manage the state of an application. The provided code snippet demonstrates how to set up a Vuex store, including defining state, mutations, actions, and getters. Mutations are used to change the state, actions trigger these mutations, and getters allow components to access the store's state. The paper then proceeds to review various state management libraries, starting with Redux. It highlights that Redux has a non-mutable store, making debugging and tracking past actions and states seamless. However, setting up Redux involves a fair amount of boilerplate code, which can be overcome using third-party utilities like Redux Toolkit. The unopinionated approach of Redux allows different teams to implement stores differently, leading to potential code maintenance overhead. In conclusion, The paper presents a comparative analysis of state management libraries for single-page applications, emphasizing the importance of reactive programming and immutable data stores. By examining NGRX and Vuex, it demonstrates how these libraries apply the principles of Redux to manage application state effectively. The review of state management libraries provides insight into their strengths and limitations, aiding developers in choosing the most suitable library for their projects. In the realm of state management for React applications, Redux stands out as a prominent library due to its battle-tested track record and strong community support. It utilizes principles such as immutable state, reducers, and actions, which are well known from the Redux ecosystem. However, it requires support from third-party tools for developer tooling and middleware. Zustand, on the other hand, offers a simpler API and less boilerplate code, making it easier to implement and set up. It also integrates well with React hooks, fitting perfectly with the current recommended approach of functional component development in React. Its performance benefits are attributed to the fact that only parts of the rendered application needing updating are re-rendered when a piece of data in the slice gets updated. Recoil, another state management library, excels in scenarios where fine-grained control over state is necessary. It breaks down state into smaller atoms, allowing for easy management of state and making pieces of state independent of each other. It also offers seamless side effect handling and creation of derived states through selectors. Like Zustand, Recoil uses a hook-based API for integration with React and provides robust developer tooling for ease of development and debugging. Server-side state management is a methodology to manage the state of an application at the server side. This approach plays a crucial role in improving application performance and consistency. Combining client-side state management techniques with server-side state management techniques provides end-to-end application consistency, synchronization between client and server-side states, improved latency, better user experience, and resiliency. In terms of use cases, form data preservation is essential in multi-step forms to ensure that user input is not lost when navigating between steps. For instance, in a registration application, user information collected in a multi-step form must be preserved as the user navigates between different steps of the form. This ensures that users do not lose their input data if they need to go back to a previous step to make changes or if they refresh the page. User authentication is another key use case for state management. Storing a user's login credentials and session token maintains their logged-in status across different pages. This prevents relogins as users navigate through the application. For example, in a banking application, once a user logs in, they should remain authenticated while navigating between the account summary, transaction history, and transfer funds pages. Lastly, maintaining a consistent view of items in a user's shopping cart across all pages and components within an e-commerce application is critical. When a user updates the quantity or removes items from the cart on any page, these changes should be immediately reflected across all other components, displaying cart information to ensure a seamless shopping experience. Here is a combined summary of pages 21 and 22. View state management in Blazor Server involves sending page content back and forth between HTTP requests, which can increase HTML page size. This approach is viable for sharing small amounts of data but has limitations for larger data sizes. An alternative approach for maintaining view state at the server side is session state, which stores user-specific data for a user's session. This state spans across multiple pages and requests accessed in the same session, making it effective for storing user authentication information, user preferences, and session state such as shopping cart contents. Application state is used to store application-level data common to all users accessing the application. This data is available throughout the application's lifespan and can be stored on a state server, in-memory, or persisted on a data store. It is recommended to persist the data on a data store to retrieve it between server restarts and for multi-server deployments. The technologies for server-side state management include Blazor Server, which stores a view state in the server memory while the connection is active. The circuit data is disposed of when the user navigates away from the page. Blazor Server is useful for storing the state of the UI being rendered, values of fields and properties in component instances, and data held in dependency injection service instances. However, since the circuit is stored in the server's memory and not persisted in a data store, it requires maintaining sticky sessions to ensure that all requests from the same browser are routed to the same server. If the request goes to a different server, the state is lost. Caching is another mechanism for storing view state, session state, and application state. The selection of technology depends on the application requirements. Redis, an in-memory data store, provides high performance by storing data in memory and persisting it in a data store. Here is a combined summary of pages 23 and 24 of the research paper. Memcache is an in-memory caching option that provides high performance but loses data on server restarts, making it less fault-tolerant compared to Redis. When selecting a data store, the choice depends on the latency and scale requirements of an application. Various storage options, including SQL databases, document DBs like MongoDB, and key-value DBs like DynamoDB, offer trade-offs between performance, scalability, and ACID properties compliance. Server-side state management techniques, such as view state, session state, and application state, play crucial roles in maintaining consistency between client and server, improving latency, and enhancing user experience. View state is simple to implement but limited to a single web page and can significantly increase HTML page size, leading to slower load times and higher bandwidth usage. Session state stores user-specific data across multiple pages and requests, creating personalized experiences, but requires careful management to avoid data loss or security issues. Application state is suitable for storing data common to all users and needs to be accessed across the entire application lifecycle, but does not inherently provide user-specific data isolation. The review of application state management techniques highlights the importance of consistency, performance, and user-friendliness in modern web and mobile application development. Key findings include the efficient handling of component-specific data using local state management techniques in popular frameworks, robust solutions provided by state management libraries like Redux and Recoil, and the crucial roles played by server-side state management techniques. The choice of application state management technique depends on the specific needs of the application, considering factors such as scale, performance requirements, and development team expertise. Certain use cases can be achieved at both server-side and client-side, and the choice of technique depends on security needs and available infrastructure. Additionally, certain technologies are more widely adopted and thus more battle-proven, and selecting an application state management technique requires considering ongoing challenges such as complexity versus simplicity and performance at scale. Application state management, ASM, faces significant challenges, including synchronization between client and server, ensuring security of sensitive user data, and maintaining cross-platform consistency. Effective testing and debugging strategies are also crucial as state management becomes increasingly complex. The emergence of new programming paradigms and architectural patterns, such as micro front-ends and server components, requires state management techniques to evolve accordingly. Additionally, optimizing for edge computing and adapting to distributed environments poses new challenges and opportunities. The industry adoption of a particular technology and technique of ASM is also important, considering factors such as community support and market adoption alongside complexity of implementation. Addressing these challenges is crucial for the continued evolution of ASM, ensuring developers can build sophisticated applications while maintaining performance, security, and user experience. The literature review highlights various studies and references related to ASM, including state management in React, Angular, and Vue.js. The references also cover modern front-end web architectures, refactoring React-based web apps, and state management of API web services using Redux on React native apps. Furthermore, the review mentions the importance of selecting a state management strategy for modern web front-end applications and simplifying state management in React Native. The review also touches on the concept of converting monolithic architecture to micro front-ends, migrating to standardized architectures, and preserving state in server-side Blazor applications. Additionally, the review mentions the different session state management options available in ASP.NET, Redis, and Memcached. The references also cover Redux state management system, usability and adaptation of React hooks, and JavaScript's uncovered parts. The single responsibility principle in software design is also mentioned, highlighting its importance in ASM.